It's going to be going down from left to right. Okay, what about a line with a slope of 0? A horizontal line from left to right. Okay. Oh, did I say no slope? I meant of 0. Okay, what about a slope of 0 should be what? Horizontal. So this should say 0 slope, sorry. And no slope would look like what? Vertical. I'm running out of colors. Okay, so remember your vertical lines always have no slope because they don't pass the vertical line test. They do not exist. Okay, they're not functions. Okay, and then your horizontal lines always have 0 slopes. Okay, so you're moving laterally, but you never have a vertical change. So your denominator is always 0, even though your numerator is always 0, even though your denominator can be anything. Okay. Determining the slope of a line containing points 3, -3, and 4, 2. What is our formula for finding slope? Change over what? Y's over change over x. Okay, a lot of us made this mistake on our algebra quiz. They put x's on top. Okay, it's y over x. Okay, so I'm going to label my points x1, y1, x2, y2. Substitute in. If you chose to label these points x2, y2 and those ones x1, y1, it doesn't matter as long as you're consistent. Like this can't be x1 and y2. Okay, they both have to have 1s, both have to have 2s. Okay, so I have 2 minus a -3 and 4 minus 3. So what was your slope? 5 over 1 or just 5. Okay. Determine the opposite reciprocals of -3/4 and 4. What is the opposite reciprocal of -3/4? Positive what? Okay. And what's the opposite reciprocal of 4? -1/4. Very good. Okay, so we're going to be using a lot of that today. Any questions on the warm-up? Awesome. Alright. So we are going to focus on parallel and perpendicular lines today. It is our last lesson before your test next class. So after today, you should be able to do that entire test review that you got last class. Remember, that has to be completed on the day of the test in order for you to be eligible to retest should you need to. Okay? So make sure that you are working on that. Okay, large parking lots have line segments painted to mark the locations where vehicles are supposed to park. The layout of these segments must be considered carefully so there's enough room for the vehicles to move and park in the lot without other vehicles being damaged. The line segments shown model parking spaces in a parking lot. 1 grid square represents 1 square meter, so we're in meters. What do you notice about the line segments that form the parking spaces? Talk about it with your table for 20 seconds. Kara, what do we think? Okay, I would agree that they appear congruent. Okay. Okay, do we know for sure? They just, what? They just look right. They just seem to be parallel. So that's what you could write. Seem to be parallel and congruent. Okay, using the line segments, figure out the slope of AB, the slope of CD, and the slope of EF. Go. Rise over run. Okay, what's the slope of AB? CD? EF? Okay, we're going to discuss what that has to do with parallel lines in a second, but turn the page to to number 3. Okay, it says extend segment AB to create line P, extend CD to create line Q, and EF to create line R. Using y equals mx plus b, find the equations of line P, Q, and R. So what it means by extend is just draw them longer. Okay, so it wants you to make them lines. Okay, and then write the equations of each of these lines. You already found your slopes, you just need to find your y-intercept. What was the y-intercept for line P? 0. What was the y-intercept for line Q? 6. And for line R? 12. Okay, so when you write it in the form of y equals mx plus b, what's our equation for line P? 3/2 x. Don't forget your x. You don't have to include the plus 0. Okay, what about for line Q? Very good. And line R? Awesome. Oh, I forgot my x. Hold on. Very good. Any questions about number 3? So, writing the equations of lines. Very basic. Okay, what do the y-intercepts tell you about the relationship between these lines in the problem situation? What does this tell us about our parking lot? So all the lines are parallel, but what? What else? They're equally spaced. What is their spacing? 6 units apart. Okay, so the lines are parallel. How do we know they're parallel? Because they have same slope. But do not have same y-intercept. The lines are all 6 units apart. Six units apart in which direction? Vertical or horizontal? Vertically. Okay, so then we have a cute little definition in that little box. Parallel lines are lines that never intersect and are in the same plane. They have the same slope. Okay, so that's the big takeaway. Parallel lines, same slope. So I would highlight that. Or underline, or whatever you want to do. Okay. Independent practice. Write an equation of a line that passes through the point P and is parallel to the line with the given equation. Okay, I'm going to do 1 with you, and then you guys are going to do B on your own. Okay, when you're given a point in a line and you want to figure out the equation of a new line that's parallel but includes the point, okay, what has to be the same between my equation and my given equation? The slope. So I know my slope has to be what? 2. Okay? I also have my point 1, negative 10. Okay? If I have an x and y value here and a slope, how can I write an equation of a line? What did you say? You can use point slope. I think that for the purpose of this course, kind of get used to just using slope intercept form, okay, because that's how it's going to be on the test. So, using slope intercept form, what would be my setup? Negative 10 equals times plus b. So I would have negative 10 equals 2 plus b. So what does b equal? Negative 12. Okay, so what's my equation on my line? Very good. Y equals 2x minus 12. So do b on your own. What does m equal? Negative 2. So when I'm putting into y equals mx plus b, I have 5 equals negative 2 times negative 2 plus b. So what did you guys get for b? 1. And my equation reads how? Awesome. Questions? Okay, hopefully that was just review. Maybe the only thing that's new is parallel lines have the same slope, but you should be able to do the rest. Okay, turn the page. Okay, the line segment shown representing parking spaces in a truck stop parking lot. 1 grid square represents 1 square meter. Use a protractor to determine the measure of VUW, XWY, and ZYW. What do you notice? So use your protractor. Okay, you may have to extend all of these lines. Okay, the first one is VUW, so I'm lining up my protractor on my vertex or my point of intersection. Okay, what is the measure of VUW? 90 degrees. What about XWY? And ZYW? Okay, so all angles are congruent with a measure of 90 degrees. What do we call angles with a measure of 90 degrees? Right angles. Okay, it said extend UI to create line P. We've already extended that, so you can just label it line P. Extend XW to create line Q. Then calculate the slopes of line P and Q. So on your own, okay, see you can calculate the slope for line P and line Q. Does line P have a positive or negative slope? Negative, and what is it? Negative 1/2. So you're going down 1 over 2 every single time. Down 1 over 2. Down 1 over 2. So negative 1/2. Line Q, positive or negative? Positive. Positive, and what is my slope? 2 over 1. So I'm going up 2 over 1. Up 2 over 1. Okay, what do you notice about the slope of line P and line Q? Opposite reciprocal. Perpendicular lines are lines that intersect to form right angles. That's extremely important. And their slopes are opposite reciprocals. So anytime you have perpendicular lines, they form at right angles, and their slopes are opposite reciprocals. Okay. Again, I'm going to do A with you. You guys are going to do B. Okay, write an equation of a line that passes through point P and is perpendicular to the line with the given equation. Okay, so currently I have P at 3, 2, and Y equals 3x plus 1. Okay, my current slope is 3. What am I going to have to do? The opposite reciprocal. So what is my new slope going to be? Negative 1/3, opposite reciprocal, my point staying the same, 3, 2. Okay, how am I going to write my new equation? 2 equals negative 1/3 times 3 plus B. What is negative 1/3 times 3? Negative 1. So what is my B value? 3, because I'm going to add 1 to both sides. 3 equals B, so what is my equation? Very good. So do letter B on your own. Start with picking out your slope, and then what your new slope is going to have to be. Okay, what's your new slope going to be? Okay, when you substitute it into y equals mx plus b, you have negative 2 equals negative 1/4 times a negative 8 plus b. What's negative 1/4 times negative 8? Okay, so what was your b value? Okay, and your new equation? Y equals negative 1/4x. Awesome. Questions over perpendicular lines? Okay, parallel lines have what? Perpendicular lines have opposite reciprocals. Last thing I want to add before we turn the page, the symbol that we use to show perpendicular lines looks like that. So perpendicular symbol. Okay, our parallel line symbol looks like this. Just like 2 backslashes. Awesome. Turn the page. Last page. Okay, on your own, see if you can do this. Find the equation of the perpendicular bisector of JM. I lied. We're not going to do it on our own. I'm going to walk you through it. Okay, in order for it to be a perpendicular bisector, what has to happen? You have to find the slope, one. But what else? You have to find the midpoint. Why do we need the midpoint? Because it has to bisect that segment. So our perpendicular line has got to go through the midpoint. How do we find the midpoint of JM? The midpoint formula. What's the midpoint formula? How do you find the midpoint? What's the midpoint formula? Very good. Add your x values together, divide by 2. Add your y values together and divide by 2. So I have -4 plus 6 divided by 2, and that's what? 1. And then I have 10 plus 8 divided by 2, and that's 9. So my midpoint is 1, 9. So plot that point. Okay? Now what do I do? Find the slope of JM. So slope of JM. What is the slope of JM? Rise over run. So rising 1, running how many? 5. So what's our slope? 1/5. Because rise over run. Okay. Now what? We have the slope of our existing line, we have the midpoint, and we want the perpendicular bisector. Opposite reciprocal, so our perpendicular bisector has a slope of what? -5. Okay? So now we have a slope. Now what? Very good. You are using this point, this slope, and writing your equation. So we have 9 equals -5 times 1 plus b. 9 equals -5 plus b. So what does b equal? Okay, so what is the equation of our line? Very good. Graph it. So where's your y-intercept? 14. And what's my slope? -5. So what direction does that go? Down how many? 5 and over. Very good. Down 5 and over 1. Okay, how do you think that we show that lines are perpendicular? You put a little square that denotes that this is a right angle. What else should I put on my graph? Congruent lines where? So on your segment, after we plotted that midpoint, we should show that those sides are congruent. Okay, so I know that process was kind of long, okay, and I guided you through it, but you won't always have me or somebody to guide you through. So you might just have to do that all on your own. So what was the first thing that we did? You found the midpoint. After you found the midpoint, what'd you do? You found the slope of your existing segment. Then what'd you do? Opposite reciprocal, and then what? You plugged into your formula. What did you plug into your formula? The slope and your midpoint. Very good. And then you wrote the equation of your new line. Awesome. Okay, last one. Distance between lines and points. Describe the shortest distance between a point and a line. So if I wanted to get from point A to the line, what kind of distance would that be? What kind of line would make the shortest distance from A to the line? A straight line, yes, but am I going to run from here all the way to here? Is that going to be the short distance? Am I going to run from here to here? Is that going to be the shortest distance? From here to here, is that going to be? What kind of line is going to represent the shortest distance? A perpendicular line. Great job. Okay, so perpendicular lines are the shortest distance. So the length of the perpendicular segment drawn from the point to the line. So the equation of the line shown on the coordinate plane is y equals 3/2 x plus 6. Draw the shortest segment between the line and the point A, 0, 12. Label the point where the segment intersects f of x as point B. Okay, so in order to do that, what do we need to plot? Not the midpoint. If we are constructing a perpendicular, what would we need to do the midpoint for? Perpendicular what? Bisector. If it said bisector, we would have to find the midpoint. Okay? Do we know what point the perpendicular line is going to cross? Not yet, right? But we do have a point that needs to go on that perpendicular line, right? Okay. So we're going to work through these steps in question 3. Okay, there is 4 of them. They are kind of long, okay, and tedious, so you need to pay attention. Okay, first thing, write an equation for AB. So, I didn't want to do that yet, but it's okay. Go ahead and draw what you think is the perpendicular line from A to the line. Okay, we know that our end goal is that this is perpendicular, correct? So, what is the slope of line AB? What is the slope of line AB? Negative 2/3. Does everybody know how we got that? Okay, I heard some no's. Okay, if we're trying to construct a perpendicular line, we have to take the opposite reciprocal of 3/2, which is negative 2/3. Okay, what is the y-intercept of my line? 12, so what is our equation? Awesome. Okay, so that's my first step. My perpendicular equation is going through the point 0, 12, okay, and its equation is negative 2/3 x plus 12. Awesome. Part B, calculate the point of intersection of line AB and the line y equals 3/2 x plus 6. How do you find the point of intersection if you don't have a calculator? How do you find the point of intersection if you don't have a calculator? Yes. Very good. You have to set the equations equal to each other and solve for x, okay? Once you solve for x, then what do you have to do? solve for y. Okay, so first let's solve for x by setting our equations equal to each other. Okay, I'm going to go ahead and, I lied, I'm not going to. I was going to convert it to a decimal, but that's okay. 3/2 x plus 6 equals a negative 2/3 x plus 12. Is there something I can multiply both sides of my equation by so that I can get rid of my fractions? Okay, I gotta multiply them by the same thing. You can multiply them by 6. What is 6 times 3/2 x? So what happens when I multiply 6 times 3/2? 9x. What's 6 times 6? Okay. What's 6 times a negative 2/3? X. Very good. What's 6 times 12? 72. Okay, so now this equation is a whole lot easier to solve than the fractions, okay? I know a lot of us aren't good with fractions, so try to ditch them when you can. Okay? So now I need to solve for x. What's my first step? Add 4x each side? Sure. Okay, so I have 13x plus 36 equals 72. Then what? Subtract 36. I have 13x equals what? 36. Then what? Divide by 13. And what does x equal? About. You can round to the nearest tenth. .8. Sounds great. Okay, now we need to figure out what our y value is, like Keishan said. So, how do we do that? Plug it into which equation? Take either of them, right? Because we set them equal to each other. Okay, so let's do that. I'm going to plug it into 3/2 x, because that can be made to 1.5. So 1.5 times 2.8 plus 6. Okay, somebody do that on your calculator and tell me what you get. 4.2. What was it? 4.2. Are you sure? 10.2. Did you add 6? Oh, I did not. 10.2. 10.2. Okay, so where is my point of intersection? 2.8 what? 10.2. Awesome. Okay, on a test, most likely your points will be clean. They won't be decimals. Okay, so at 2.8, 10.2, that is where your point of intersection should have been. Okay, so my graph is not anywhere close. So maybe yours is better. 2.8, 10.2. Okay. Now it says calculate the length of AB. So we have A at 0, 12. We're going to pretend that B is currently at 2.8, 10.2. How do we calculate that distance? The distance formula. Okay, so your distance formula, hopefully we're memorizing it by now. x2 minus x1 squared plus y2 minus y1 squared. Okay, and I'm using the point 0, 12 and 2.8, 10.2. Okay, I'm going to label them x1, y1, x2, y2. Take a minute and solve for the distance. So substitute into your equation. Solve for the distance. Round to the nearest tenth. Make sure when you have negatives and you're squaring them that you put them in parentheses. A negative squared can't be a negative. Okay, what'd you give us a distance? Point what? 3.3, very good. So this should have been 11.08 in your radical, and that is about 3.3 units. Okay, and so you would just write that in words. What is the distance from point A to the line? It is approximately 3.3 units. Okay, on a test, it will not be scaffolded like this and giving you step-by-step equations. You have to know that you have to calculate the equation, calculate the point of intersection, and then find the distance. Okay, so we broke it up for you so that you would have a step-by-step process. There's questions on your review. I don't know off the top of my head, but it's like a triangle on a graph, and it tells you to find the perpendicular bisector of all the sides. I don't know what question it is. Yep, that one. What question is that? 15 is a prime example of where you have to apply this, and it's not going to give you all the steps. Okay? Alright, I'm going to hand out the assignment that goes with today's lesson, and then